Hello, welcome back. Today we're going to be looking at the 2008 AB Calculus AB FRQ number 5. So let's get started with part A. So part A says on the axis provided, or the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. And it says note, use the axes provided in the exam booklet. So it wants us to draw each of our little slope tangent lines in this set of axes right here. So to do this, to find the slope of each line, which for the AP test, it only matters that your slope is positive, negative, or 0. So if the slope at a point, for example, were 2, this line and this line would get the same amount of credit. It just matters that you get the sign correct. So anyways, what we're going to have to do to find the slope at each of these points is plug in points, the points that we're plugging in being each of these little black dots, into this differential equation. So I'll draw in red just to show we're starting with this top point right here. So that point would be -1, 2. So -1, 2. And now we're going to plug these numbers into this equation. So the y is 2. So we're going to have 2 minus 1 over x squared. So -1 squared is just 1. And that's going to be equal to +1, right? 1 over 1 is just +1. So all we have to do is go to that point. I'll draw the lines in blue. All we have to do is go to that point and draw a positive line since the slope is positive. Once again, it doesn't matter if this number was 1, 2, 3, 1,000. As long as our slope is positive, we get the same amount of credit for the AP test. So then we're going to continue that process for all the points. I'm not going to do all of the points in this video, obviously, because that would kind of get redundant after a while. But let's try one more point so you can get an idea of what you're supposed to be doing. And then I'll reveal the finished slope field at the end. So let's try this point here next. So that would be 2, 1, 2, 1. What we're going to do is plug 2 and 1 into this equation here, because this dy over dx is the derivative of some other equation. So for every point that we plug in, we'll get the slope of the tangent line at that point. Even if the original equation doesn't necessarily have a point there, that's what the slope would be. But anyways, plug in 2 and 1. So we're going to have 1 minus 1 over x squared. So 2 squared is equal to 0 over 4 is equal to 0. So the slope at that point is just going to be a flat line. Whenever it's 0, you're just drawing a flat line. So now I'm going to fill in the slope chart and you can check your other answers. So here's the completed slope field. So as long as these top 3 points are all of positive slopes, it doesn't matter how positive. As long as they're all positive slopes, you would get full credit. As long as these middle points are all 0 slopes, so flat lines, you get full credit. And as long as these bottom 3, or the red ones, are all negative, you would get full credit. And note that there's no points or no slopes on these 3 points on the y-axis. So if you just look over at the problem, the reason for that is because at all of the points on the y-axis, x equals 0, right? By definition of a y-axis, x is going to equal 0 at all these points. And if we plug in x to this equation, let's say we have, for example, this point here is 0, 1, right? 0, 1. We plug in 0, we have 0 minus 1, 1 minus 1, because y is 1, over 0 squared, which is just 0. And we can't have a number over 0 that's equal to undefined. So that's why we have no points in the middle. Okay, awesome. Now we can look at part B. So part B asks us to find the particular solution y equals f of x to the differential equation with the initial condition f of 2 equals 0. So that's important. We're going to need that information. Not a great underline, but whatever. So the steps to finding the particular solution are as follows. I'll list them here. So the first thing we're going to need to do is separate the variables. So separate variables. And then after we separate the variables, we need to integrate both sides. And then we need to find c. After we find c, we need to isolate y. So there's our 4 steps. So now let's see how that works. So our differential equation is dy over dx equals y minus 1 over x squared. So to start separating our variables, I think the first thing we should do is multiply both sides by 1 over y minus 1. Because if we multiply both sides by 1 over y minus 1, these y's are going to, or y minus 1s, sorry, are going to cancel out. And we're going to be one step closer to isolating all of the y's on one side and all of the x's on the opposite side. So now we have 1 over y minus 1 dy over dx equals 1 over x squared. So now we want to get that dx over to the 1 over x squared side so we can have all the x's on one side of the equation. So what we can do is multiply both sides by dx. So then this will cancel, right? Because this is dx over 1 and this is essentially 1 over dx. So those cancel. And now we have dx on this side. So now what we have after we successfully separated the variables is 1 over y minus 1 dy equals 1 over x squared dx. So we've completed the first step. We've separated the variables. So now what we need to do is integrate both sides. So I'm going to erase this work. Okay, awesome. Now let's integrate both sides. So start by looking at the left. So to integrate this, we can first of all change it a little bit by writing it like this, because y minus 1 to the power of negative 1 is the same as 1 over y minus 1. So from there, we know that, for example, x to the power of negative 1 is ln absolute value of x. So y minus 1 to the power of negative 1 is ln of the absolute value of y minus 1. And then that's going to be equal to this. So what we can do for this side is the same logic. You don't necessarily need to do this, but I like to do it because I feel like it makes it easier to visualize and think about. We can change it to x to the power of negative 2, because x to the power of negative 2 and 1 over x squared are the same thing. And then from there we can use our 1 over n plus 1 times x, sorry, should be an x. We can use this formula, 1 over n plus 1 times x to the power of n plus 1. And what we can do with that is take our negative 2 plus 1 is negative 1, and then negative 2 plus 1 is negative 1 again. So that's going to be negative x, right? Negative 1 times x to the power of negative 1. So now we've successfully integrated both sides. So when we ended the last step, I actually forgot to write c, but we should have a plus c on the right side here with x. So now we can try to find what that c value is actually equal to. And we can use our initial condition of f of 2 equals 0. So x is 2, we can write it like this, and y is 0. So now we're plugging in 2 and 0. So let's do it. ln of negative 1 equals negative, that's negative 2, so it's going to be negative 1/2, right? Because we plug in 1/2, or sorry, we plug in 2, and since it's the power of negative 1, it gets flipped to the bottom. So we have negative 1/2 plus c. Okay, so now we have to try to isolate c to get what it's equal to. And we have ln of the absolute value of negative 1, or otherwise known as ln of 1. And ln of 1 is equal to 0, because remember ln, here, I'll write it up here. ln is the same as log base e. So log base e of 1 equals what? Equals what? So that means e to the power of that question mark is equal to 1. And anything to the power of 0 is equal to 1. So that's why ln of 1 is equal to 0. But anyways, we have 0 equals negative 1/2 plus c. And now we can flip this 1/2 to the other side and make it positive 1/2 equals c. So now we have successfully found c. So those first three steps are where you earn most of your points in terms of like the AP test. But now the final step, the final point, is isolating y. So this is our equation now with c plugged in. Ln absolute value of y minus 1 equals negative x to the power of negative 1 plus 1/2. So what we want to do is get this y alone. So it's going to end up being y equals whatever we find it to be. So the first thing we can do is put everything to the power of e. Just for some clarification on this step about putting them both to the power of e, the logic behind that is that this ln of absolute value of y minus 1 is really log base e of the absolute value of y minus 1 is equal to negative x to the power of negative 1 plus 1/2. And what by the definition of logarithmic functions, this is telling us that e to the power of this, so e to the power of negative x to the power of negative 1 plus 1/2 is equal to this, so absolute value of y minus 1. So maybe just abstracting away from this and saying, oh, I'm just going to set this, or e to the power of this and e to the power of this, and they cancel. Maybe that's an easier way to understand, but this is what's actually happening, or actually what the logic is behind that step. So when you have e to the power of ln, they're going to cancel out, and you're just going to end up with whatever's right here. So now we're going to have absolute value of y minus 1 equals e to the power of negative x to the power of, or negative 1 plus 1/2. So what we can do from here is test both when this is positive and when this is negative, because this is absolute value, so we have to test positive and negative. So let's start by doing y minus 1 equals e, right, positive e, to the power of negative x to the power of negative 1 plus 1/2. So the way we can test it is using our initial condition again of x is 2 and y is 0. So let's go ahead and plug that in. We're going to have negative 1 equals e to the power of negative 1/2, right? Because plug in 2, flip it to the bottom 1/2, and then it's negative, plus 1/2. So this is going to be 0, right? It's going to be 0. E to the power of 0 is 1, and negative 1 does not equal positive 1. So what that leads us to conclude is that the correct, here I'll kind of erase this here. You obviously wouldn't need to erase it on your test booklet, but what that leads us to conclude is that it should be y minus 1 equals negative e to the power of negative x to the negative 1 plus 1/2. Because if we plug in 2 comma 0 to this, we're going to have negative 1 equals negative 1, which is exactly what we want it to equal, obviously, because negative 1 equals negative 1 is a true statement. So this is correct, and now we have to isolate y, so we just move our negative 1 to the other side. So we go y equals negative e to the power of negative x to the power of negative 1 plus 1/2, and then flip that, make it positive, so it's going to be plus 1. So this here is our final equation. Okay, awesome. So now we're done with part B. Let's move on to part C. Part C is pretty quick, pretty easy. So it tells us for the particular solution, y equals f of x described in part B, which is this right here, the equation we found in part B. Find the limit as x approaches infinity of f of x. So find the limit as x approaches infinity of this. So we can go ahead and write that out. Limit as x approaches infinity of negative e to the power of negative x to the power of negative 1 plus 1/2 plus 1. So what we're going to want to do with this is just plug in infinity for x. So if we plug in infinity for x, we're going to end up with negative e to the power of negative infinity to the power of negative 1 plus 1/2 plus 1. And if you recall, when we plugged in 2 for x, this became negative 1 over 2, right? Because this to the power of negative 1 makes it flip to the bottom, or puts it under 1 rather. So we can apply the same logic, move that up here, and go negative e to the power of negative 1 over infinity plus 1/2 plus 1. And now, as far as we're concerned, 1 over infinity is essentially equal to 0. Because if you take 1 and you divide it by 2, now you have 0.5 or 1/2. If you take 1 and you divide it by 10, now you have 0.1. So as that number under 1 increases, the value of 1 decreases. It's essentially just going to be 0. So we have negative e to the power of 0, or negative 0, 0, same thing, plus 1/2 plus 1. So e to the power of 1/2 is the same as root e, but we don't necessarily need to write it like that. We can just write e to the power of 1/2, which is what I prefer to do because there's less room for error if you're making less changes to what you've already written. So our final answer is going to be negative e to the power of 1/2 plus 1. And that is the entire question done. Thank you very much for watching. I hope this video was informative and helpful. And if it was, please like, subscribe, and recommend the channel to your friends if they also need help in their math class. And please also comment any requests for any video. If you request anything, I'll probably make it. So thanks a lot for watching, and please like, subscribe.